Well, good day everyone. It's great to be here, and even better to be talking to you about a project that since we were invited to become involved last year, it's been a really interesting journey, so really great to be here to be able to share with you part of that story. I will say before I start that it's pretty hard to sum up everything that's been going on into this assessment, looking at Glenshera Swamp. But fortunately, I can point you to our website. If you put in some of these terms, you'll track down a PDF copy of the report that's just been finalised. So if you'd like to know a lot of the detail that sits behind this talk, please go there and have a look, because I'm going to be showing you lots of pictures and skimming over a lot of information. Before we start, I thought I'd just introduce Glenshera Trust, because unlike most of the other organisations talking at this conference who probably don't need any introduction, I assume that there are people in the room who don't know who we are. We're a 4-year-old not-for-profit organisation, works in both largely South Australia and Victoria, but also a little bit of work in New South Wales. And that sums up our purpose in terms of what's in our deed of trust, but the way I like to summarise it to people and what Glenshera Trust is all about, we deliberately trying to position ourselves to fill the gap that sits between academia, people on the ground, and the policy world that government interacts and creates for people to work within. And by doing that, we're trying to basically get smarter decisions and things that happen on the ground that are supported by sound science. So that's the general gist of what we are as a not-for-profit organisation. How we work is perhaps a little bit different to what people expect from a not-for-profit organisation. We actually have, I guess, a business model that's got 3 different streams. That explains it there, but basically we seek grants for ideas that we pursue and that we come up with. We offer our expertise as consultants, which tests people's understanding, I suppose, of what a not-for-profit is about, but any money we make on those jobs actually helps run the organisation, so that's been a really important part of the way we operate. And finally, something we're getting up and running now is offering people the opportunity to donate towards worthwhile causes that we're working towards as well. We work between Melbourne and Adelaide, and that's our team, and been pretty busy across that part of the world. If you're interested to find out more, the website will be at the end of the talk, so you're welcome to go and have a look around at what we do. Needless to say, with today's talk, and in terms of where we operate, a real focus for our organisation is working in wetlands, and hence the theme for today's talk. That's actually a photograph of a property that we purchased a couple of years ago with the support of the Native Vegetation Council and Nature Foundation SA, called Eaglehawk Waterhole, which has seasonal wetlands on it and is a pretty specky place when it rains. Didn't look like that last year, unfortunately. But in the upper southeast, 1,700 acres, and a large scale, one of the largest scale restoration projects to happen in the agricultural regions of South Australia, so something we're very proud of. Right, now I guess as a backdrop for talking today about Glenshera Swamp, one of the reasons why we think focusing on hydrological restoration in wetlands makes sense. There's a few things that back this up, I guess. First of all, working with water. It's the key ingredient if you're going to work with wetlands, and the thing that makes me most excited to talk to you about what wetlands can deliver when you restore them is the fact that the outcomes that you achieve are self-sustaining, meaning that if you get the hydrology right, then nature generally can roll on and take care of things from there on, unlike a lot of our programs which require ongoing human intervention. I don't need to talk about climate change, but let's just say that if things are drying, then buffering against climate change is a pretty important action, very strategic thing to be doing. Something that I like about working with water is that it forces you to think outside of the linear boundaries of reserves and working across boundaries. And the payback time is pretty exciting, because you can often get results in a faster turnaround than you get from terrestrial ecosystems. To give a really quick example of a site that I guess really spurred my interest in working with wetlands, a project that I worked on many years ago when I was working with the state government in the southeast. These are some of the works that happened at a place called Pick Swamp in order to achieve an outcome like this. So cows grazing in paddocks, backfill the drains, just add water. That's only a few weeks later, mind you, after that previous shot, and then come forward 5 years, and that's natural regeneration of aquatic habitat. This is now a Ramsar site, so this is what's possible when we pick sites strategically and just add water. Over the last 4 years, we've been restoring wetlands on public land. These are sites in Western Victoria. Working with the community, it gets people involved and interested. A lot of public land has these stories of modification before they became reserved, and that leads in pretty nicely to today's talk, actually. Just before I start on that, I'll just show a before and after image of works at one of those sites, Gooseneck Swamp, when we converted the trial structure to permanent work, so that's before. And we've managed to actually backfill some drains in the Grampians, and this is what a swamp looks like when you restore water levels in it. Pretty fantastic. Right, that's the background, and why, I suppose, having done all those things over the years with wetlands, we were invited, don't know if Jason's in the room from Tenure, but invited to have a look at what the possibilities are for Stipiturus Conservation Park, Glenshera Swamp, one of the most important fluorio swamps in the zone south of Adelaide, nationally threatened community, and historically hasn't really had the hydrological part of the equation looked at in great detail. So it was an opportunity to take a fresh look. The things that we consider when we do this are obviously land tenure considerations and wetland extent, history of the site, understanding what values are associated with it, looking at wetland type, where it is in the catchment, importantly what the potential to restore the site is, and then designing restoration methods to suit that context. First part of that is having an understanding of what this site was like. Now, we're lucky at Glenshera Swamp that it was mapped, and wetlands surveyors back 100 years ago tended to draw the boundaries of wetlands and tell you a bit about what they were like. Thankfully, not always, but in this case they did, so we have this early description from 1899. First aerial photography was in 1949, and you'll see there's already some drainage works here that as we roll through these images, you'll notice the land clearance, the slicing and dicing, the drainage, these things have all rolled on. Accelerated from the 40s onwards, that post-World War II era of clearance and development and drainage, which leaves us with the site as we know it today, which is what you've got there. And they're the drains that are out of this site, which a lot of them are hard to spot when you're out there, which is one of the reasons why this issue has snuck up on people. There's still a swamp there, but there's definitely this network of drains which has been superimposed on it. So trying to tease apart site hydrology. A bit complicated because this site interacts with groundwater. It has surface inflows. The drains interact with those features on the site in the way that is illustrated there on the diagram. Transferring that into an understanding of how those drains are actually influencing the site's hydrology. Well, we were really fortunate during the time that we were doing the assessment late last year that before it stopped raining, and it stopped raining for several months, pretty much as soon as we visited the site, but luckily we'd had a reasonable rainfall period up until early September, and the drains were flowing. The catchment was wet. We were able to see exactly which drains are the main carriers of flow, because not all drains on this site are equal or impacting the site in an equal way. And another interesting thing that's affecting the way water moves is this area of expanding Phragmites, which people who've worked in fluorio swamps will be familiar with as a bit of an issue with managing this ecosystem type. And you'll see there that we were able to map as the extent of this area of Phragmites has changed through time based on the aerial photography. And interestingly, it's caused a deflection of flows into, as you'll see there, the deflection of flows around that patch where previously that was the main direction in which flow was carried was in this direction, and with the Phragmites patch catching sediment, reducing the efficiency, it's actually deflecting flows around into this drain. So there's a few things that you can piece together, that there's physical changes and then there's biological changes which follow, which actually then can cause further physical changes. It's an interesting sequence of events. And that's that area where the drain discharges, where the Phragmites patches has established. In terms of zones of, what we try to do to tease apart the equation of what's going on out there, because it's pretty complicated, understand which different zones, or break the property up into zones, I suppose, to understand how to then formulate a restoration response. First thing to think about is this area where the natural creek line used to discharge water into the top of the swamp. So there's a zone there where drainage has modified inflows. There's the main swamp itself, which stays wet year round and is fed by groundwater, which is another key zone in the swamp. There's this area to the north where the drains actually run up the slope, and they're affecting the way water moves out of the slope itself. And bearing in mind this is an area with very sandy soils, and where water actually, one of the ways it makes its way through a catchment is subsurface as much as it does through the creek lines and things like that. There's a lot of lateral movement of water through soils, being a very sandy, having very sandy soil types. There's this area where those main surface flows were discharging into the swamp downstream, where that Phragmites patch was pointed out. And then there's this zone downstream where the drains become deeper and are drawing down on the main swamp zone as well. So in terms of tackling restoration, a couple of the main principles that underpin our thinking and bringing together hydrology and ecology. So the main principle we wanted to get people thinking about with the site was, okay, the clear problem here and what was intended with draining the site when it was being used for agriculture was to speed the movement of water through the site and out of the site. And our intention for restoration is really to reverse that process. So let's increase residence time, slow the movement of water through the site, make better use of it for environmental purposes. And ecologically, of course, we're hoping that will cause a positive shift in the trajectory of some of the key values in the swamp that people who are interested in fluorio swamps are extremely concerned about, with the drying trend that's being observed in the fluorio at the moment. So the 6 proposed actions for restoring the swamp, which not necessarily in priority order, but just in an order. So, and this is probably the first thing that we would look at doing, is diverting the inflows of that creek line so that the water has to make its way through the main swamp rather than bypassing the southern edge of the swamp, which meets that criteria of slowing the water down, making better use of it in the main swamp itself. The creek line itself, before it reaches that point, was actually straightened, and we're lucky that they didn't go and tidy it up so well that you can't actually see where the original creek line is. You can actually find it if you go looking, and in fact that's supported by this information, which is one of the parts of the project that I won't go into any detail about. I think there's another talk on at this conference about it as well. The people that have helped us acquire this LiDAR data or elevation information on the site, we've been able to use this to help determine the original meanders in the creek, and if we go to the extent of putting back all of the original meanders, where you would install blocks, which you can see there marked in red. So really interesting how you can use different pieces of information to piece together the restoration proposal. In terms of the drawdown zone and the main swamp, reducing the ability for that drainage network to be drawing not just surface water but groundwater out of the system is a really important action that we can do to again slow movement of water out of the site. The drains upslope and the dam upslope, which are catching and drawing bank seepage away, and other actions we can look at, and making sure that southern bypass drain doesn't continue to operate by making it inoperable. So they're the sort of actions that we've come up with. Next steps, we're in the process of talking to the Jason from Natural Resources AMLR at the moment, working out what comes next, and there's some monitoring we'd like to set up, but also that first task, which could be done quite inexpensively, of diverting the flows back into the top of the swamp. And hopefully with time over the next couple of years it'll be possible to implement these actions that I've been through in stages. Hopefully starting this in time for this winter, but over the couple of years ahead. In terms of wrapping up, this project's we've been welcomed, which I really appreciate, because most of our work to date has been in the southeast and southwest Victoria, and to come and work more actively in another region means that people have to show some trust, and the agency staff up here, Conservation Council particularly, sharing their knowledge, the locals, lots of interested people who've helped us out, sharing their information to help piece together a proposal here that I think everyone's comfortable with and is really keen to try and make work. It simply we wouldn't be at this point if it wasn't for that generosity that these people have shown in sharing their knowledge and helping get us to this point. So with a bit of luck, we might be back here in the next year or two sharing with you some of the story of what happens next as a result of implementing the restoration proposal. Before I wrap up, I will just mention too that For people who we worked with, I've got a free copy of this report for anyone who wants to grab me afterwards, and I might, in case anyone who we have talked to and has had input into this project, I'll just go up the back and outside if anyone wants to grab one, because there might be a few people who we consulted with, and these have literally just come off the press. If anyone else would like a copy, you can get it as a PDF off our website. Or, look, in order to cover our costs, we probably need to ask for, say, $10 or something like that. If anyone else wants to come and grab a copy off me after the talk, you're welcome to. I've got a few here in a box. So thank you very much for listening, and enjoy the rest of the afternoon.
Thanks, Mike. Questions, please? Everybody's happy with it.
Everyone's almost happy.
I noticed a lot of those, in the images you had a lot of those sandbags going across there.
Yeah.
Is that to slow the movement of water?
One of the reasons that we use, and those are geofabric sandbags for those, and what we call them restoration trials. So one of the reasons that that's been a really helpful method for some of the sites that I showed you from Western Victoria is being on public land, and the same probably applies with Stipiturus. Rather than going in with heavy machinery and backfilling drains in one step, building a temporary sandbag structure allows us to manipulate the site, try before you buy, and it means that a lot of the pressure that people are put under to decide a sill level and go and build it to certain standards, and it has to be decided, and then people get really edgy about making really fixed decisions before you start. We can take all that out of the equation by saying, right, and the best part about it is, and the community will come and help us build this thing, and then we watch it in real time. We can take a layer off, add a layer, and then if it's on a private landowner's property, for instance, then they get to see, yep, happy with that. We can work out where inundation extent's going to be based on what people actually see, rather than, models are great and we use them, especially using the elevation data, but there's nothing quite like actually understanding how a site's going to behave, particularly in sites where you've got vegetation types that shield the actual surface, which means LiDAR isn't as effective at giving us an accurate ground surface reading when you've got dense native vegetation types. So there's some of the reasons why we use that as a method, interim method.